Howdy, Algebra 2 students. It's a beautiful Saturday morning. I'm here at school making more videos. I was up until 2 a.m. trying to grade assignments that have been emailed to me. Nowhere near being done, but that's okay. Let's get started with the next section. We are still in chapter 7. We are in section 7.6, and we're going to be solving radical equations today. It says to solve a radical equation, you need to isolate the radical. Now remember, a radical means that you've got the little radical sign. Sometimes though, we don't see those radical signs. So if you see a variable that's being raised to an exponent that is a fraction, remember that also represents a radical because your denominator represents the index of the radical. So basically our goal right now is to get the radical by itself, and then from there we'll solve. So at the beginning of this lesson, we're doing stuff we've been doing since Algebra 1. We're just going to be isolating something, and then we'll throw in a little bit of new stuff. So if we take a look at example number 1, we have the cube root of x minus 4 equals 0. So the first thing that I want to do is I want to get the cube root of x by itself. And so the thing that needs to go away is that minus 4. And so to do that, we're going to do the opposite of what we see. So we are going to add 4 to each side. So we end up with the cube root of x equals 4. All right, well now the goal, since we have the radical isolated, is we want to get rid of the radical. So if you pay attention to the index is a 3. How can I get rid of a cube root? Easy. I'm going to raise both sides to the third power. Remember, whatever you do to one side, you have to do to the other. And a cube root and cubing something, they're going to cancel each other out. They undo one another because they're opposites of each other. So over here, we're now left with x because the cube root and the cube have undone one another. Over here we have 4 to the third power, and 4 to the third power is 64. And that's going to be our solution for example 1. All right, so number 2, we want to get this radical right here by itself. So there are two things that need to go away. First of all, we want to try to get rid of the 5. But secondly, we have to get rid of that minus sign. So first let's start with the 5. How do I get rid of a positive 5? Easy. I'm going to subtract 5 from each side. So when we do that, the 5's cancel, but I have to bring down a negative 4th root of x equals negative 5. So the next thing that I want to do is try to get rid of that negative that's out front. Now what that means is that it's understood that I have a negative 1 out front that I'm multiplying times the 4th root of x. So since what I see is multiplication, I'm going to do the opposite of multiplication, and I'm going to divide both sides by negative 1. So now over here, I've got the 4th root of x equals positive 5. So once you get the radical by itself, we're going to do like we did in the last problem. The index is a 4, so that means that I need to raise both sides to the 4th power. Because my 4th root and my 4th power, they're going to cancel each other out, which now leaves x by itself. And 5 to the 4th power is 625. I had to think about that one for just a moment. And there's our solution for example number 2. All right, example number 3 looks different because I don't see a radical sign, but I do know that having an exponent that's a fraction to a variable means that I have a radical. So what this really means is that this is a square root function because my index or denominator is a 2. But before I can worry about that, I need to get rid of the number that's being multiplied by that, and that's that 2. And so since I see multiplication, we're going to do the opposite, which is division. And we're going to divide both sides by 2. So now I have x to the 3 halves power equals 125. Okay, so now we have a problem kind of like one we haven't seen before. Our goal is to get x by itself. That means we want an x to the first power. But right now we have an x to the 3/2 power. Well, how can I get that 3/2 to turn into a 1? Well, if you go back to Algebra 1, remember if we had a fraction that was being multiplied and we wanted to get rid of it, what did we do? We multiplied by its reciprocal. But since this isn't, I'm multiplying it, I'm raising it to the 3/2 power. So now I'm going to raise both sides to the reciprocal of 3/2. And reciprocal just means you're going to take your fraction and you're going to flip it. So that 3/2 turns into 2/3. But we know that whatever we do to that left side of the equation, we have to do the exact same thing to the right side of the equation. So over here, 3/2 and 2/3, power to power, they multiply together, so they cancel each other out, which leaves us with just an x, which is great because that's what we want. Over here, I'm going to rewrite this. I'm going to make it look like a radical. So I've got 125. It's going to go underneath my radical sign. The denominator of 3 is going to represent my index, and the numerator of 2 is going to represent my outside exponent. So I'm going to ask myself, what number can I multiply by itself 3 times to get 125? And that's a number we've dealt with a lot in this chapter, and so that's going to give us a 5, but we still have that outside exponent of a 2, which we now have to apply. And 5 to the 2nd power is 25, and so 25 is going to be our final answer. Now, one thing I can tell you, if the fraction part kind of freaks you out, because some of y'all don't really like fractions, let me go back to this step real quick. When we had x to the 3/2 power, if you want, you can rewrite that. That would be x. We would have had an index of 2, and we would have raised that to the 3rd power. The 2 was our denominator, so it is the index. The 3 was our numerator, so it was the outside exponent. So we could have done something like that, and if you wanted, you could solve it from there. But to me, I find that it's going to be easier here just to, if I have that exponent that's a fraction, if I just raise both sides to the reciprocal of that fraction, it really makes the problem pretty easy. So let's try another one like that. Couple things I need to get rid of, because our goal is this is what we want to get by itself. So I need to get rid of the 3, which is multiplying. I need to get rid of the 5, which is addition. Remember, when you're solving equations, you're kind of doing the order of operations backwards. So typically multiplication would come before addition, but since we're going backwards, we want to get rid of that addition. And how do we do that? We subtract. So I'm going to subtract 5 from each side. So now I have 3x to the 4/3 power equals 243. Now I can get rid of that 3, which I see is multiplication, so I'm going to do the opposite of multiplication. I'm going to divide both sides by 3, and I'm going to get x to the 4/3 power equals 81. And here we come to the new step that we did in the last problem. I need to get rid of that exponent of 4/3, so I'm going to raise it to the reciprocal, which is 3/4, but I have to do the same thing on both sides. Well, the 4/3 and the 3/4, they cancel each other out. So now I have x all by itself. Over here, I'm going to rewrite this in the form of a radical. So the 81 is going to go underneath the radical sign. The denominator of 4 turns into the index, and the numerator of 3 turns into that outside exponent. So I'm going to start by asking myself, what number can I multiply by itself 4 times to get 81? And that answer is 3. And then I'm going to take that 3 and raise it to the 3rd power. And so my final answer for x is going to be 27. I hope we're doing good so far and you're following along with your notes. Okay, so next example. Again, you want to isolate your radical. Here's the radical that I see. So right now, I'm not interested in messing with what's underneath the radical. All I'm interested in, is getting that radical by itself. And so I see a +2, which means I have to do the opposite. I'm going to subtract 2 from each side. So I have the square root of 4x minus 7 equals 3. Oh, that didn't turn out quite so right, did it? equals 3. Okay, so we've isolated the radical. Now we need to get rid of the radical. I don't see an index, but remember that just means that it's understood to be a square root function. And so how do I get rid of a square root? You may have guessed it. I'm going to square both sides. Again, whatever the index is going to tell you what you need to raise both sides to in order to get rid of that index. So over here, we're going to be left with a 4x minus 7. We no longer have a radical because the square root and the squared have canceled each other out. On the other side, 3 squared turns into a 9. And now I have a really easy problem to solve. So we're going to add 7, which now gives us 4x equals 16. And we see multiplication. So we're going to do the opposite. We're going to divide both sides by 4. And our final answer is going to be 4. So again, you just want to isolate the radical and then go from there. Same thing here. The goal, isolate the radical. So don't worry about what's underneath it. Just worry about the things that are on the same side with it. And I see a minus 7 on the same side with it, and I need to get rid of it. So we're going to add 7 to both sides. So we have the cubed root of 2x plus 8 equals positive 6. So I can see that my index is a 3, which tells me I'm going to have to raise that side to the third power. And whatever I do to one side, I have to do to the other. So cube root and a cube power, they're going to cancel each other out. So we're going to be left with 2x plus 8 equals 6 to the third power, which is 216. Now we have a pretty easy linear equation, so we're going to subtract both sides by 8. So we have 2x equals 208. And then lastly, I see multiplication, so I'm going to divide both sides by 2. And 2 goes into 208, 104 times. And there's our answer for example 6. All right, example 7. We want to get the radical by itself. There are 2 different things going on. There's multiplication happening with the 7, and there's subtraction happening with the 3. Again, remember, we're going to do the order of operation backwards. So normally multiplication comes before subtraction, but we have to do the opposite of that. I need to get rid of the subtraction, so we're going to do addition, and we're going to add 3 to each side. So we have 7 onto the 4th root of 3x plus 1 equals 14. My goal is to still get this by itself. So what I see right now occurring is multiplication of the 7. So we're going to do the opposite, and we're going to divide both sides by 7. And now we have the 4th root of 3x plus 1 equals 2. So if I want to get rid of that radical sign, I'm going to look at that index of 4 and raise both sides to the 4th power. My radical sign goes away completely, which brings out the 3x plus 1. 2 to the 4th power turns into 16. And now we keep solving as usual. So I'm subtracting 1 from each side. And then lastly, I'm going to do division because I saw multiplication. And I'm going to get that x is 5. All right, a couple more to go. Let's take a look at number 8. We want to get rid of the radical. I would encourage you to pause it right here. Try to do it on your own just for a moment. So pause. And then I'm going to pick up now. If I want to get this by itself, I've got a couple things I need to get rid of. I have multiplication happening between the negative 4 and the radical, and I see addition. But I have to get rid of the addition first. So I'm going to use subtraction. And it's going to turn that 17 into a 12. Then I'm going to get rid of the multiplication. So I'm going to use division to do that. And so now I have the square root of x minus 11 equals negative 3. Now I'm going to get rid of the radical. I don't see an index, but remember that's understood to be a 2. So I'm going to raise both sides to the 2nd power. And I have x minus 11 equals 9. And then lastly, I'm going to get rid of the 11 by adding it to each side, and we're going to get that x is equal to 20. And there we go. All right, number 9. So we're back to seeing the radical in the form of having a fraction exponent. No big deal. We want to isolate this first. So the very first thing that I need to do is get rid of the minus 6, and I'm going to do that by adding 6 to each side. So I have x minus 8 raised to the 2/3 power is equal to 9. So I now have my radical by itself, but I need to get rid of that exponent that's a fraction. So remember we talked earlier, and we said that to get rid of that, we're going to raise both sides. And I'm only using brackets because I already have parentheses over here. If you want to do another set of parentheses, that's okay. I just like the look of seeing different grouping symbols. But I'm going to raise this to the reciprocal of 2/3, which is 3/2. And then whatever I do to that side, I have to do the same exact thing to the other side. So remember what's going to happen. The 2/3 exponent and the 3/2 exponent, they're going to cancel each other out. So we're going to be left over here with an x minus 8. On the right side, I'm going to rewrite that in the form of a radical. So underneath the radical, I have a 9. The denominator, 2, is my index. And the outside exponent is going to be a 3 because that's what the numerator was. So I have to work on that side a little bit. The square root of 9 is going to give me a 3. And then I have to raise that 3 to that outside exponent of 3. And 3 to the 3rd power is 27. And then our last step here, we're just going to add 8 to each side and get x equals 35. All right, one more. All right, so let's do this one together. Again, we want to get the radical by itself. We want to isolate it. So I'm going to start by getting rid of the plus 2, and I'm going to use subtraction to do that. So now I have 3x minus 5 raised to the 3/4 power is equal to 8. So the radical has now been isolated, but I need to get rid of the radical. So again, this is where I'm going to raise both sides to the reciprocal of that exponent. So I'm going to raise it to the 4/3 power. Again, I have to do it to both sides. So what I know happens is those two exponents cancel each other out. We now have 3x minus 5 on the left. I'm going to rewrite this in the form of a radical. So 8 is underneath the radical. The denominator is a 3, so that's my index. And the numerator is a 4, so that's my outside exponent. I'm going to work inside of the parentheses. So the cube root of 8 is 2. And then we're going to raise that to the 4th power. And that's going to turn that 2 into a 16. And now we're just going to finish this up using our Algebra 1 skills. We're going to add 5 to each side, which now turns the 16 into a 21. And then we're going to divide by 3. And we're going to get that x is 7. All right, so I'm trying to remember what assignments I have for you guys this week. I think there's some quizzes assignments. Those are located in Ren Web under homework. Remember that those are going to be time sensitive, and it tells you in there when it is due by. So typically I think it gives you a couple of days to try it. I want to reiterate that with those you can try it as many times as you want. So if the first time you take it you get a 60, don't be satisfied with that 60. You can go back, retake it as many times as you want until you get a 90 or 100 or whatever that grade may be. I also think there's some worksheets going on this week. The important thing I want you to know is I love feedback. So if you're struggling, please, please, please shoot me an email. Go to the website, the blog, got questions, post your questions there. I'm trying to answer those as quickly as I can. I'm trying to answer the emails that I'm getting as quickly as I can. It's a little bit overwhelming to grade via email because it's so hard to do. I'm so used to being able to write down feedback and give that back to you, and now I'm having to write it down on paper and then type it and then wait for your response as you email it back to me. So bear with me on that, but I am trying to go as fast as I can. But let me know if there's something that you're struggling with, and other than that, hope you have a great day.